Hi guys, so today we're going to be looking at some part of the specification. Hopefully you'll make some links between the whole of this topic so far. So let's skip ahead. These are the words from the specification, the link between the coastal process, time, landforms and landscapes in the coastal environment. And what this actually means is the coastal processes that we studied, so there's your erosion, deposition, mass movements, weathering, winds, currents, tides, all of that part, how quickly they kind of act, what landforms they make, and then what the overall environment is. Now we did about the difference between landforms and landscapes, and how the Holderness coast is a landscape of erosion, but you might have beaches within that, you might have a cave arch stack stump and so on and so on. So the landform is like the individual, and the landscape is a collection, a bigger spatial scale. So that's part of this as well. So I'm not going to talk you through this. Pause this so you can have a little sort of read of it. But basically what this is saying here is that we tend to say a landscape erosion or a landscape deposition, but it's actually much more complex than it. We will have mass movements happening, which then might lead to deposition occurring and so on and so on. It might change over the course of the year if you've got bigger waves in winter as opposed to summer with the wind's energy. Tides change as we move through the lunar cycle, your spring tide versus your neap tide, and so on and so on. So all of these things interact to create a general what's going on. But this will be changing all the time over the course of a day, over the course of a month or a year and beyond. We are now seeing a bigger change with climate change, so future scales will change even more. So pause, read through this, and then we'll go on to the next one. Okay, so basically, any landscape you look at in the coastline will give you clues as to what's happened in the past. So this is what it's talking about with these layers. So you might well find there are relic cliffs, stumps which are away from the coastline, and that indicates that there's been sea level change in the past. And then if you look really closely, your ripples and runnels, one of my favourite parts of the beach, down where the tide's just gone out and the sand's quite hard. These are showing you on a really small scale about the sediment movements, the erosion that's going on, and so on and so on. So there are clues everywhere. They will change between the temporal scale of like really recent over to like, hundreds of thousands of years if we're talking about the relic cliffs and so on and so on. So that's all stuff you can talk about when you were asked about this in an exam question. Key thing to remember though, no matter what scale you're talking about, there is still a logical order, still a sequence of events that lead to that clue in the landscape. And that's what I need you to focus on. So I'll again pause, would you pause me, and read through that, and I'm going to talk you through the table on the next page. Okay, so here we've got 4 examples of clues that, or 5 examples of clues that you could look for in the coastline, and the different sequences that you would talk about for those particular examples. So the first one's the easiest one. Cave arch stack stump. This is a process sequence. What happens first, second, third, fourth? What leads to the development of that stump at the end of it? And so on and so on. So that's a developmental process sequence. Then we've got something a little bit more abstract, such as if you see there's a narrow beach at the bottom of a cliff, or a wide beach at the bottom of a cliff, what can you pick up from that? And this is to do with the rock type. The rock type at chalk is it's heavily faulted, it's got lots of bedding planes and vertical joints, and that is going to then collapse with mass movement. It's going to be rockfall in bigger chunks. The chalk is then soluble, so will dissolve relatively quickly. So that might lead to a narrow beach, pebbly beach, whereas sandstone is going to be eroded much more by abrasion into the small sand particles, and that's going to then, because sand particles, when the water hits it with the wave, it's got less space between it. It kind of like filters it down, so it becomes tighter, so it becomes a bit more compact and doesn't get dragged away as easily. So that might form a wider one. So that's a causal sequence. One thing has then caused that thing to happen. Knock-on effect. Now, the third one is by far the most complex. This might make sense, and I'll come back to this when we do Odisha later on. But basically, we're talking about big areas here. So is there a river that's bringing in a huge amount of sediment that then affects that particular coastline? So in Odisha, which is an area in India, it's got six rivers discharging into the area, and that then leads to specific features that you see, such as offshore bars and spits and stuff happening in that area. So that's a much bigger sort of area, and it often involves inland or maybe even offshore, that then causes the features that you'd see. And then we've got the final one, temporal sequence. So basically time. And this is where you've got simultaneous things happening at one time. So for example, you could talk about how multiple factors are influencing the coastline at the same time. So sea level rise is the key one. So you've got basically eustatic and isostatic working together to make a bigger change in the area. And then we've got successive, like something that happened in the past that you can still see now. So like your relic cliffs, your stump and stack that's a long way away from the beach. This isn't happening at the same time now. This is like leftovers from like the past. So I know those words are quite complicated, but basically we've got a sequence of development. We've got one thing then leads to another thing happening, and so on and so on. We've got clues like, oh, this has happened because of this particular rock type. We've got whole big areas coming together in the spatial sequence. We've got things happening all at once to amplify something that's going on, or clues left from the past. So that was just talking through that. Go back, have another little look through. Don't overcomplicate it. It is just trying to think about the coastal processes like wind, erosion, deposition, so on and so on, how they happen either quickly or slowly, and that leads to landforms occurring, the speed at which they occur, so on and so on, and then whether that forms erosive or a depositional landscape. Is it a very fluctuating landscape? Will that change over time? Okay, so that's all that means. And that leads me to your main task for today. From the words on the next slide, I want you to either do a massive concept map, finding links between them. Really think, go back to the booklet, chapter 1 especially, even though it's got a lot of the chapter 2 stuff in it as well, but you'll need a little bit of revision on the first stuff. Or you can try and put these words into a massive paragraph explaining how they are all connected in some way, shape or form. Good luck with that. Send me it. You can just attach it in Teams if you want. That's usually easier than show my homework. Just send me a message because it's got your name on it basically. I look forward to seeing them.